All right, today we are digging into one of the greatest cold cases in the history of science. Seriously, we're going to be detectives going back to the early 1900s to look at the clues, the suspects, and one absolutely radical theory that tried to explain the very planet we're standing on. This is the story of how we figured out that our continents are actually on the move. You know, every great mystery has that one clue that just grabs you. And for this one, it's been staring us in the face for centuries. Just look at any world map. Have you ever noticed how the bulge of Brazil seems to fit almost perfectly into that curve of West Africa? For the longest time, people just shrugged it off as a coincidence. But then one guy looked at that same map and had a thought. What if it's not a coincidence? What if it's a clue? Now, to really appreciate how wild that idea was, you've got to put yourself in the shoes of a geologist back then. They were completely stumped. They were finding fossils of the exact same land animals on continents separated by thousands of miles of ocean. They saw massive mountain ranges that seemed to just stop at the coast, only to magically reappear on a different continent. The theories they had just couldn't explain it all. So, at the time, there were pretty much two leading ideas. First, you had the shrinking apple theory. The thinking was the Earth is slowly cooling down, and as it cools, it contracts, and the surface wrinkles up, creating mountains, kind of like an old apple. Then, to explain those weird fossils, you had the sunken land bridges theory. This idea that massive continents used to exist between, say, Africa and South America, and then they just sank. The trouble was, these theories contradicted each other, and worse, neither of them really held up to scrutiny. Yeah, the evidence just didn't add up. I mean, scientists did the math and figured out that for the Alps alone, to form from a shrinking Earth, the planet would have had to cool by an insane 2,400 degrees Celsius. Just not possible. And the whole land bridge idea, it totally violated a basic law of physics called isostasy. See, the lighter continental rock floats on the denser rock of the mantle. An entire continent sinking is like watching an iceberg just decide to sink to the bottom of the sea. It just doesn't happen. So, into this scientific deadlock walks our main character, Alfred Wegener. And here's the thing, he wasn't even a geologist. He was a German meteorologist, an expert on weather and the atmosphere. He was a total outsider. And because he was an outsider, he wasn't locked into all those old, failing ideas. He looked at the exact same clues as everyone else, but he saw something completely different. This was it. This was the bombshell. Wegener looked at all the confusing, contradictory evidence, and he proposed one startlingly simple solution that could explain everything at once. He asked, what if the continents aren't fixed in place? What if they've been moving, drifting horizontally across the face of the Earth for millions of years? Now, this wasn't just some wild guess he pulled out of thin air. In his 1920 book, Wegener laid out his case like a master detective, presenting one piece of evidence after another. So let's open up his evidence locker and take a look inside. First, you've got the jigsaw fit we already talked about. But then, get this, he showed how mountain ranges, like the Appalachians in the US, line up perfectly with mountains in Scotland and Scandinavia if you just push the continents back together. Third, the fossils. He pointed to creatures like the Lystrosaurus, a land reptile whose fossils are found in Africa, India, and Antarctica. These guys definitely weren't swimming across oceans. And finally, the climate clues, evidence of ancient glaciers in the middle of the Sahara Desert and coal from tropical plants found in the freezing Arctic. It all pointed to the same, inescapable conclusion: the continents had to have moved. But honestly, Wegener's most brilliant argument was pure geophysics. He pointed out something really fundamental about our planet. If you map out all the elevations on Earth's surface, you don't just get one smooth curve. Instead, you get two very clear, very distinct peaks. There's one for the continents, mostly sitting just above sea level, and then there's another, much deeper one for the ocean floor, way down around negative 4,700 meters. So that begs a huge question, right? If the Earth's crust was all made of the same stuff, you'd expect a random jumble of heights and depths. You'd get a single bell curve. So why these two very specific separate levels? Well, Wegener argued it's because they're not made of the same stuff at all. And his answer was just beautiful. He said that the continents are made of a lighter kind of rock he called sial, think granite. The ocean floor, on the other hand, is made of a much denser rock he called sima, think basalt. What that means is the continents aren't just sitting there. They are literally floating on top of this denser layer, like massive icebergs of granite floating in a sea of basalt. And hey, if continents can float, well, then they can also move. And that one simple concept suddenly became the key that could unlock some of the biggest geological mysteries, like how the world's giant mountain ranges were formed. So how do you get a massive mountain range like the Andes? Forget the whole shrinking apple thing. Wegener said it's way simpler. Picture South America drifting westward. Its leading edge is plowing into that dense, resistant ocean floor. The lighter continental rock has nowhere to go but up. It just buckles, crumples, and folds under the immense pressure, creating a huge mountain range. It's basically like pushing a big rug up against a wall. The rug has to wrinkle up. So there you have it. An amazing theory that explains the puzzle piece fit, the fossils, the mountains, the whole two-level crust thing. I mean, this was a slam dunk case, right? Wegener must have been celebrated as a genius. Well, no, not even close. The scientific community at the time basically put his theory on trial. And let's just say the verdict was harsh. You can just hear the sheer frustration in Wegener's own words from his book. He faced incredibly fierce and sometimes really personal attacks. Famous geologists called his ideas utter damned rot. He was openly mocked at conferences. His work was just dismissed as this crazy fantasy from a guy who didn't know what he was talking about. So why? Why did they hate it so much? Well, for one, Wegener was an outsider. He was a meteorologist stepping on the geologist's turf, and they did not like that. Second, and this was the biggest hole in his case, he couldn't explain what force could possibly be strong enough to push entire continents around the planet. But honestly, the biggest reason was probably just old-fashioned dogma. The idea of a fixed permanent Earth was so deeply rooted that most scientists just couldn't let it go. Alfred Wegener would never live to see his theory accepted. He actually died in 1930 on an expedition in Greenland, with his ideas still considered total heresy. But the story doesn't end there. Decades later, in the 1950s and 60s, new technology allowed us to finally map the ocean floor. And what we found there, seafloor spreading, was the smoking gun. It was the engine, the very mechanism for continental drift that Wegener had been missing. The outsider was right all along. Wegener's story is just such a powerful reminder that science isn't about a set of facts written in stone. It's a process. It's about questioning everything. The most outlandish, radical idea of one generation can become the fundamental truth of the next. And it really makes you wonder, doesn't it? What accepted scientific fact of today is just waiting to be overturned by the radical idea of tomorrow?